The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to be reviewing for the Outcome 5 test. The test will be tomorrow. There'll be no regular class meeting tomorrow. Basically, you just need to complete your test by 11:59 p.m. tomorrow evening. I've gotten some requests from some students for some specific questions. So we're going to start with those. This is from, let's see, this is from, oh, I know, before I do that, you may notice if you look that 5C.1 is gone. I decided the best way to deal with it was just to delete it. So, and any questions that are on the chapter review or the chapter test that are those type of questions, do the best you can with them. But if you miss part B, I think I'm just not going to count those, but just do the best you can with it. Okay. I will grade them fairly, I promise. All right. Anyway, so we're going to look at, come on here. This is from 5, there we go, 5C.2, number 5, which you should see on the left side of your screen from WAMAP. Write the number in standard notation. 5.6 times 10 to the 19th power divided by 1.4 times 10 to the 25th power. All right, if I take 5.6 divided by 1.4, I get 4. And then that's times 10 to the top exponent, 19, minus bottom exponent, 19 minus 25. Let's see, what is that? 19 minus 25 is -6. But the directions say standard notation. So I don't want scientific notation. I want standard notation. So 4.0. Oh, but we're going to move the decimal point to the left 6 places. And I'm going to add a bunch of zeros. Let's see. 1, 2, don't need this here. 3, 4, 5, 6. So 0.000004. 1, 2, yeah. Okay, and we'll check here, see what they said. 0.000004. So there's 5 zeros after it. All right, any questions about that? Now let's take a look at problem number 7. And this says, write the number in standard notation, 4.8 times 10 to the 18th power over 1.6 times 10 to the 19th power. Okay, so on our calculator, 4.8 divided by 1.6 should be 3 times 10 to the 18th power minus 19th power is -1. But again, we're to write this in standard notation. It looks like the student tried to write it in scientific scientific notation. Anyway, standard notation, let's see here. We would move the decimal point to the left 1 place. So 0.3 should be the correct answer. And there we see that it is. All right, that was all from that student. Give me a minute here. I'm going to change the viewing window to the whiteboard screen. And then hang on. Let's see here. Okay. Yeah. Chapter review. Number 24. Okay. So number 24, and this is from the chapter review or objective review from 5. Simplify completely. Yeah, I'm not sure the student got this right, but apparently they still had some questions. So we'll take a look at it. And we start out with -3 w to the 4th power over w squared times x to the 5th power, the whole thing to the -2 power. All right, there are several different ways I can go about doing this. I could start by just taking everything and applying the -2 exponent from the outside, but I think what I'm going to do first of all is I'm going to do some simplification inside, okay? So I'm going to get -3, then the w to the 4th power divided by the w to the 2nd power would be w to the 2nd power in the numerator. And then still x to the 5th power in the denominator, all to the -2 power, okay? So I decided to do that move first, which kind of follows order of operations, do what's inside the grouping symbol first, okay? Next, I'm gonna take the reciprocal of that entire contents. So I get x to the 5th over -3w squared, and that's gonna change the sign of the outside exponent. Any questions about that?
No, I think that's what was happening is I was stacking it wrong.
Okay, okay. So then I'm going to get x to the 5th squared over -3 squared w squared squared. A power raised to a power, you would multiply the exponents. -3, the quantity squared, is a +9. A power raised to a power, you would multiply the exponents. And there's the final answer. All righty, those were the ones that were requested. So now let me just open it up to y'all. Whatever you want to do, whatever you want to look at, it's your review time. So let me know if there's specific questions you want to look at, or if you want me to go over the rules or whatever. I'll open it up for you.
Can we go over the rules again?
So the ones that have to do with the shortcuts for the properties of exponents.
Yes.
Okay, yeah, that's what I was talking about. I just wasn't sure if that's what you wanted. All right, let's see here. We have, if we're multiplying 2 powers with the same base, we add the exponents. So that would be one of the rules. Let me go over some examples of that. X cubed times x to the 7th power would be x to the 10th power. X cubed times y to the 7th power, however, is not like x to the 10th, y to the 10th. The rules do not apply here, right? Because we don't have the same base. So we need to know when to use the rules and when not to use the rules. So this is when to use the rule. All right, do you need more examples of that one, or is that okay?
No, I'm okay with that.
All right, let's see. A power raised to a power, you multiply the exponents. So let's say I've got x cubed to the 7th power. That would be x to the 21st power. So notice the difference between these two, okay? Do you need more examples of that, or are you okay with it?
Okay with that.
All right. Let's see. Dividing 2 powers with the same base, you subtract the bottom exponent from the top exponent. So if I have x to the 7th over x cubed, that's x to the 7 minus 3 power, or x to the 4th power. However, if I have x to the 7th over y cubed, that's just x to the 7th over y cubed. It only works when you're dividing powers with the same base, okay? Let's see here. If you have a product raised to a power, you attach the outside power to each factor in the product. So for instance, if I have x, y, the quantity cubed, that's x cubed, y cubed. If I have x squared y to the fourth all to the seventh power, that's x squared to the seventh power, y to the fourth to the seventh power. But then I go back up and see this rule again, and that's going to be x to the 14th, y to the 28th. So I actually used two rules in that particular situation. We okay with that?
Yes.
All right. I want to get to the right page just to make sure I don't forget one of the rules. Let's see, we've done that one. Okay. All right. If we have a quotient raised to a power, we attach the power to both the numerator and the denominator of the quotient. So let's say I have 3 over w all to the fourth power. That would be 3 to the fourth power over w to the fourth power, or 81 over w to the fourth power. Do you want more examples of that rule?
No, that's okay. Thank you.
Okay. Let's see. Some of the shorter rules. A base raised to 0 power equals 1. And a base raised to the 1 power is same as the base without writing any exponent. In other words, if there's no exponent written, it's got an implied 1 as an exponent. Okay. So there's those two rules. So for instance, 7 to the 0 power is 1. And if we have like x times x squared, that's x cubed, because there's an implied 1 there. Okay. So that gives us those. And then we've got the situation where we're dealing with negative exponents. If I have a base to a negative power, that's 1 over the base to the opposite of the exponent. So the sign changes. So for example, 7 to the negative 2 power is 1 over 7 to the positive 2 power, which is 1 over 49. This works the other way as well. If you had this, so if I had 1 over w to the negative 2 power, that would be w to the positive 2 power over 1, or just w to the 2 power. So you can move it downstairs or upstairs, and it's going to change the sign of the exponent. Let's see here. If you have something like this, a to the negative n over b to the negative w, that's the same thing as b to the positive w over a to the positive n. Switching them makes both exponents positive. Likewise, if you have something like this, you can rewrite it like that. And then from there, you would go on and use other rules to simplify it further. So those are all the rules. Does anybody want any examples of more of the rule, more examples of these rules? Do I need to go back previous pages because you didn't get it all written down? You can always come back later on the video, but anything else to do with just the exponential rules, the shortcuts and stuff? All righty. Keep in mind, unless it's involving scientific notation, typically we write a final answer without negative exponents. You always get rid of those negative exponents by using the rules. In the event that it's a problem with scientific notation, then you have to use whatever exponent applies to the problem. It could be a positive number, it could be a negative number, okay? So for instance, let's say that I'm asked to write this number in scientific notation. So that's going to be 3.0 times 10 to the what? -2 power. So you wouldn't write that, for instance, like that. Even though that's true, you'd leave it in scientific notation if it asked for that. Okay. So again, be careful to read the instructions. I cannot emphasize that enough. I know that on some previous tests, some of you missed a lot of points. It would say something like writing your answer as a fraction, and you'd write a decimal, or it asks for a mixed number and you'd write a decimal or something, but you basically didn't follow the directions. So don't just think, oh, this looks just like the last problem, and do it the same way. Read the directions. Nag, 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 nag. Okay. Anyway, what else? Anybody, anything you want to look at, either from the chapter review or whatever? This is your time.
I think I'm okay. You covered the one I needed help with.
Okay. Anybody else? Anything? All right. Well, I will be back this afternoon at 1:15 with an office hour, should you change your mind. Again, tomorrow, the test, basically you can take the test anytime now up until, make sure it's done by tomorrow night, 11:59. Once you open it, you gotta finish it. Okay. All right. Well, have a great rest of the day. I hope you do well in your test. And I'm going to go ahead and stop the recording